March 16, 2026, GitHub. A developer filed issue 21903 against the Vite build tool. The problem: component CSS was auto-imported in one order during development and the reverse order in the production build. Different Cascade winners, different visual output, same code, same project, different environment. The report captures the specific tension between Tailwind and plain CSS. Tailwind structures styling through a utility vocabulary and a build process. Plain CSS structures nothing and relies on the developer controlling the Cascade directly. When the build process reverses the Cascade order, Tailwind users lose control they assumed the framework was handling. Plain CSS developers lose the control they assumed they had maintained. The choice between these two approaches is a choice about who is responsible for the Cascade and what the failure looks like when that responsibility is misunderstood. Adam Wethan was building a side project called KitTail in 2017 when he arrived at the insight that became Tailwind CSS. The existing CSS frameworks felt wrong. Bootstrap's predefined component classes carried a visual identity that was hard to escape and required fighting the framework to customize. His solution was to stop naming things. Instead of writing a .button class in a CSS file, compose the button from small single-purpose utilities applied directly in the HTML. Background color, padding, border radius, text color, each its own class. The CSS file gets shorter. The HTML gets more specific. The first alpha shipped in November 2017. Version 1 reached stable in May 2019. Wethan co-wrote Refactoring UI with Steve Shoger, and the book's approach to consistent spacing, color, and typography scales was directly embodied in Tailwind's defaults. Tailwind UI launched in early 2020 as a commercial component library. It became the revenue engine for Tailwind Labs. Version 3, in November 2021, introduced the just-in-time engine, generating only the CSS classes actually used. Version 4 in January 2025 rewrote the processing engine in Rust, delivering builds 3 to 5 times faster and removing the manual content configuration that had been a documented source of production failures. The State of CSS 2025 records Tailwind as the #1 CSS framework by active use, retention at 70 to 80%, and awareness above 90%. The same period saw Tailwind Labs downsize after AI tools reduced documentation traffic and disrupted the revenue model. The framework that rose to dominance, partly because AI code tools defaulted to its syntax, was also challenged when those same tools reduced the documentation traffic that once fueled its growth. Håkan Warmli proposed CSS at the European Nuclear Research Laboratory in Geneva in October 1994. CSS1 became a W3C recommendation in December 1996. The Cascade mechanism Lie designed, which resolves conflicts between competing style rules by priority order and specificity, gave the language both its flexibility and its most persistent failure mode. In 2003, the CS Zen Garden demonstrated that CSS-based design could produce radically different visual results from identical HTML markup, and the industry moved from table-based layouts to the semantic HTML plus separate style sheet model that every styling approach in web development is still built on. CSS in 2026 is significantly more capable than in 2016. Native nesting allows related rules to be co-located without a preprocessor. The has selector allows a parent element to be styled based on what it contains, a capability CSS lacked for 30 years. The @layer rule provides explicit cascade order control. Define layer priority once, and all rules in a higher layer always beat rules in a lower layer, regardless of specificity. Container queries allow components to respond to their containing element's size rather than the viewport. The Cascade is still producing the same failure modes it produced in 1996. December 2024, a developer posted about a minified style sheet with specificity clashes that had become impossible to predict. April 2024, a developer described CSS as the most difficult technology they had dealt with after years working with it. The modern features address the architectural causes of those failures. They require adoption discipline that does not happen automatically. The failure modes from both approaches in the research period are specific and informative about what each one costs. Tailwind's cluster in the 6 weeks following the January 2025 version. 4. Release. The @apply directive, which Vite 3 developers used to extract utility combinations into named classes, stopped working as expected. Default heading and button styles vanished. The Cascade layer behavior changed. 3. Documented incidents inside 6 weeks. The Vite issue from March 2026, where the production build reversed the auto-import order of components CSS, sits in the same category. Tailwind operating correctly, but the build environment changing what correct produces. Plain CSS carries a different failure structure. The dev-to-production Cascade divergence reported by a developer in July 2024, where local and production environments showed different visual output from the same code, is the environment dependency problem that Tailwind was partly designed to solve. The specificity accumulation problem, documented in the December 2024 Reddit post and the April 2024 complaint, is the global namespace problem that Tailwind avoids by construction. Tailwind utility classes do not conflict with each other. 2 elements with the same utility class will receive the same styles. 2 elements with the same custom CSS class name may receive different styles depending on which rule wins the cascade. The Vite issue illustrates the boundary precisely. Tailwind resolves the developer's specificity conflicts by design, because utility classes do not compete with each other. It cannot resolve the build tool's ordering conflicts. Plain CSS hands both categories of conflict to the developer from the start, with no framework layer to absorb either one. The choice between Tailwind and plain CSS is not a choice between a good tool and a bad one. It is a choice about which constraint structure the team prefers to work inside, and which failure mode they are better equipped to manage. Tailwind constrains the styling vocabulary. Colors come from a defined scale. Spacing comes from defined increments. Typography comes from defined size steps. A developer composing from those utilities produces consistent results by default without maintaining a separate design system or enforcing conventions through code review. The cost is HTML verbosity that accumulates without component extraction discipline, version migrations that can break existing patterns, and a build dependency that sits between the CSS and the browser. The version 4 breakage cluster and the Vite cascade reversal are both failures of the build layer, not the styling model. Plain CSS provides the full cascade without constraints. Any color value, any spacing value, any architectural pattern is valid. The freedom to build exactly what the design requires is total. The cost is that the cascade is the developer's direct responsibility. Naming conventions, specificity management, and encapsulation strategy all require active maintenance rather than framework enforcement. The @layer rule, native nesting, and the has selector reduce that overhead significantly. They do not eliminate it. They require a team that applies them consistently from the start or invests in retrofitting a code base that predates them. For a team iterating quickly on a component-based design following common patterns, Tailwind solves the most common CSS decisions before they arise. For a team building a bespoke design where framework constraints would require working around them, or where long-term maintainability outweighs prototyping speed, plain CSS with the modern feature set is the more expressive and less dependency-heavy option. The cascade belongs to whoever writes the most specific rule. Tailwind decides that. Plain CSS leaves it open.